Hello, and welcome to the SolidCAM mill turn training videos. This video is the initial introduction to mill turn applications and machines. We will start at the beginning, so this might be a review for some of you, but keep following this series as we progress through projects from beginning through more advanced operations. Mill turn machines can be referred to as different things. You may have heard the terms multitasking machines or mill turn machining centers. These are advanced machines that combine both turning and milling abilities into one system. Machines can be configured differently depending on the needed applications. A traditional two-axis lathe will have an X and a Z axis, whereas mill turn machines can include XZC or XYZC axis configurations where the main spindle can act as a controlled axis for milling operations. The machine may have an upper turret to hold tooling, a lower turret to hold tooling, or both, upper and lower turrets that can address the primary main spindle and or the sub-spindle if the machine is so equipped. Some more advanced machines can have any combinations, including perhaps an upper B-axis head as well. If we're looking at the part on the screen, we can see that it requires both turning operations as well as milling operations. So I can see my OD profiles of my turning shaft, the different ODs, as well as milling operations on various faces and directions. I have some toolpaths already on this part, and we will dive into these in future videos, but here's an example of my roughing toolpath for turning, and perhaps a profile toolpath with the tool approaching the part from a different orientation to machine this little slot. And including some other operations as well, perhaps like that wrapped feature on this part component as well. Let's take these operations into machine simulation. So I'm going to capture the entire operation list and go into simulation, and in this case, machine simulation. This particular example is an Okuma Malthus 3000. The machine has a lower turret that can hold either stationary, static tools, or live driven tools, as well as a B-axis head that can rotate to address the part from different angles. So we can see the B-axis here moving, how it can address the main spindle or perhaps the sub-spindle as well if we handed the part off to the sub-spindle. I'm going to go ahead and play the simulation. So during the simulation, we're going to see a combination of both milling and turning operations. This configuration allows for machining of complex parts in a single operation or setup. This will improve both part efficiency and accuracy, as well as reducing part handling. This will also remove the need to set up milling operations on a dedicated milling machining center for the secondary ops. Some key capabilities of mill turn machines are that the machine can act as a lathe, whereas the part can spin, but can also act as a mill where the tooling rotates and the part is stationary. The spindle then acts as a driven interpolated C-axis instead of acting as a main spindle spinning the part. Drilling, tapping, and milling operations can be performed on faces, sides, or the ends of the part components. The machine may have a Y-axis to allow for off-center positioning to handle more complex machining geometries. Additional capabilities of mill turn machines can include the ability to position the upper and lower turrets and main and sub spindles independently or combined to transfer a part from the main spindle to the sub spindle for back of part machining operations. Thank you for watching this initial introductory overview video, and I hope you'll follow along through the complete series.